Okay, so today we're going to look at perpendicular and angle bisectors, the second objective in chapter 5. We've looked a little bit with angle bisectors and perpendicular bisectors in previous chapters, but we'll kind of get some more detailed information today. So starting with the perpendicular bisector theorem, okay, tells us this, that if a point is on the perpendicular bisector of a segment, okay, then it's equidistant from the endpoints of the segment. So we get this if statement. If line PM is perpendicular to line AB, so we've got PM perpendicular to AB, and if we know that MA equals MB, meaning that M is the midpoint of AB, again we can see we have perpendicular, we've got those congruent marks, then what we know to be true is that PA is equal to PB. So we connect the point out on that line to the endpoints of the segment there, right? And we get those equal distant segments, PA and PB. Those have to be congruent or equal in length. This theorem also comes with a converse. And so the converse of this, again, we just switch the if and then. So we get this. If a point is equidistant from the endpoints of a segment, then it's on the perpendicular bisector of the segment. So we start the other direction now. We're looking at segment AB. If we have a point not in that segment, like point P, and that point P is equidistant from the endpoints, right? PA and PB are equal in length, they're congruent. Then what we know to be true is that the line PM is perpendicular to AB, right? There's our perpendicular, and MA equals MB. So we have a perpendicular bisector to segment AB, right? It cuts segment AB in half, and it's also perpendicular. Okay, so a little example with this. We want to find the length of side AB here. And we're going to do this using the perpendicular bisector theorem. Well, we'll start with this right away. Notice that we've got a segment here, AD, which we know some information about. One, right, we've got a pair of congruent sides here. AD equals DC. Let's just go ahead and make mention of that. AD that doesn't look right, so let's go ahead and try that again. AD equals DC, that's a little better. Okay, and we also notice that BD is perpendicular to AC, right? We've got our little right angle mark here. All right, so if that's the case, what we know then is that this line BD is a perpendicular bisector of AC, and so point B should be equidistant from the endpoints of that segment, AC. In other words, the length of AB should equal the length of BC, right? AB should equal BC. Well, if we know that, we can then take the expression for each of these lengths, AB, which is 4x, right? And that needs to be equal to the length of BC, which is 6x minus 10. So if we've got this equation, we should be able to solve it for x. So we'll do this really quick here. We'll subtract 6x from both sides. Cancel those guys. Negative 2x equals negative 10. We can divide both sides by negative 2. Get rid of those. And we find out that x is equal to a positive 5. But we're not done. We're not asked to find x here. What we're asked to do is find the length of AB. And we know AB, again, to have a measure of 4 times x. But now that we know x is 5, AB is 4 times 5, or 20. Okay, so we looked at perpendicular bisectors, right? But what about an angle bisector? What if we cut an angle in half? Let's see what happens here. Well, again, we've got a theorem and its converse about this. And so for the angle bisector theorem, it tells us this. If a point is on the bisector of an angle, okay, then the point is equidistant. All right, so here's what we get. We've got some angle here. Right, angle PQR, right? We've got angle PQR, all right? And we know that it ray QS bisects that angle. So ray QS bisects that angle, right? Cuts it right in half. And we can see that. We've got our marks here, right? That angle's been bisected, cut in half. Then what it tells us then, if that's true, then the distance from S to QP, or excuse me, SP and QP are perpendicular, and SR and QR are perpendicular. Okay, if that's all true, then we know that SP and SR are equal in length, right? If we know all that's true, then the distance or length from S to P and the distance or length from S to R have to be the same, right? Those are equidistant. All right, so there we go. If you've got an angle bisector, then a point that's on that angle bisector is equidistant to the two sides of that angle. All right, now, the converse of this theorem. Converse tells us this. Again, we just switch the if and then. If a point on the interior of an angle, it's in the inside, is equidistant from the sides of the angle, meaning it has the same distance, then the point is on the angle bisector. So now we know this. We've got, again, this angle PQS. There's our nice little angle PQS, right? And if we know that SP is perpendicular to QP, right? We've got this right angle here. And we know that SR is perpendicular to QR, right? We've got perpendicular here. And if we know that these two distances are the same, this will catch up with me here, okay? Then is this. QS bisects angle PQR, right? So that segment, or that ray, QS, right, bisects angle PQR, cuts it directly in half. Now, one other thing I want to note here, and you're going to have to make room for this on your page, but we also want to talk about the distance from a point to a line. So let's just say I've got some line here, okay? And let's just call this line AB. Well, if I pick any point that's not on this line, any point at all, I'm going to pick point C. And I want to find the distance from C to that line. Well, that distance from C, any point not on a line, to a line, is always found on the segment that is perpendicular to it. Okay, so if I make a segment that's perpendicular, and I just happen to call this point D, okay, so the distance from C to line, oh, don't have to write line, we don't need to write that, to line AB, right, is the length of CD, okay? The length of CD. And the important thing here is that CD, that segment, has to be perpendicular to line AB. So if you have a point not on a line and you want to find the distance from that point, like C to line AB, you've got to find the segment that's perpendicular there, okay? The length of that segment should give you the distance from C to line AB. All right, so can we use this? Well, we should be able to. We want to know what is the length of RM here, okay? Well, let's look at our drawing. We've got an angle. We've got an angle LNQ, right? There's angle LNQ. And what we notice here is we've got this point R. And if we talk about the ray NR, right? We talk about ray NR, we notice that those angles are marked congruent. So it tells us that NR, right, that ray bisects angle LNQ, right? Cuts it directly in half. And we also notice that if we look at these segments, RM is perpendicular to one side of the angle, and RP is also perpendicular to one side of the angle. So because all of this is true, what does it tell us about MR and RP? Well, those two segments have to be congruent, right? These two things have to be congruent or have the same length. So again, we can set up an equation here in which MR has to equal RP. Or in other words, MR, which is 7x, has to equal RP, 2x plus 25. Right? So all we want to do first is just solve this equation for x. We'll start out by subtracting our 2x. Okay, we can cancel these. We're going to move this work over here a little bit. 7x minus 2x, that'll give us 5x equals 25. Divide both sides by 5. And we find that x is 5. All right, so we've got x. But again, we're not asked to find x. We want to find the length of segment RM. Okay, well, segment RM, again, is 7x. And since we know that x is 5, that's 7 times 5, or 35. And again, that should also then not only tell us RM, but it should also give us RP. RP and RM have to be the same. So just as a side note, we can also say that RP is also 35, right? Those two things have to be the same. All right, so one last problem to look at here. We're going to buzz through this pretty quick so we can keep the time short. We got, looks like about 5 questions here, 6 questions to answer based on this drawing here, and we can kind of take a look at all the different things we have. But let's start with this first one here. How far is M from KL? Well, again, remember, distance from a point to a line is always found on the segment that's perpendicular to it. And so if we look at line KL, right, we've got this segment from point M that's perpendicular to KL, and that should give us a distance, and that's marked already as 8. So how far is M from KL? That is 8. How far is M from JK? Well, again, look at JK. You've got a line. Point M is not on that line, so again, its distance is on the segment that is perpendicular to it. That would be right here. Those two sides, ML and MJ, are marked as congruent. So if ML is 8, then also JM or MJ is also 8. So there we go, 8 for those two. Okay, so number 10, how is KM related to angle JKL? I've got a couple things up here that I don't really want you to see yet, but that's okay. So we're looking at how KM, the blue one, is related to angle JKL, kind of this angle down here at the bottom. Well, we start with this. Let's just prove first that these two right triangles are congruent. And we should be able to do that because we've got two right triangles, LMK, JMK. They have a pair of legs that are congruent, right? The two sides marked with the one black tick mark. And their hypotenuses are the same. It's side KM, so by the reflexive property, they're congruent to each other. So these two triangles are congruent by hypotenuse leg, meaning that not only is these pair of sides congruent, right? Because all corresponding parts are congruent, then we can say these angles here are congruent as well as these angles up here. But the idea is then, because angle JKM and angle LKM, because those two angles, let's mark those, JKM and LKM, because those are congruent, right, that makes MK an angle bisector of angle JKL. So we can say it's an angle bisector. So now they want us to find the value for X in number 11. Well, that should be pretty easy. Because it's an angle bisector and these two angles are congruent, 3X has to equal 54. Divide both sides by 3. And X equals, if I'm not mistaken, I am mistaken, X is what? 18. 18, there you go. Thank you, Mr. Stearns. X is 18, there you go. Find the value of X, 18. Now, find the measure of angle MKL, okay? Find the measure of angle MKL. Well, for some reason that's already marked. It's 54. There's really no point in doing any work there. The last one, find the measure of angle JMK and LMK, okay? JMK, let's put these in green, JMK and LMK. Well, again, we're dealing with a right triangle here, so if we even were to kind of make a little side note, let's just draw one of those in. There's K, L, M. Here's our 90 degrees. This is 54. Right, those three things have to add up to 180. So just kind of doing this work in my head here, 54 and 90, that's 144. Subtract that from 180, and I believe it's 36. You can double check your work on that. Does that seem right? Yep. Yeah, 36, right? So you add the three angles together, the 54, the 90, and the measure of angle LMK. Subtract it from 180, and there you go. You get 36, which is also then a measure of angle JMK, because again, that angle's been bisected. All right, there you go. That's objective 2, perpendicular and angle bisectors.